Welcome, my dear learners, for this course on engineering graphics. In this module 4, we were discussing on development of lateral surfaces of solids. Moving ahead, the problem number 3 of our discussion states that a pentagonal prism of base height 30 mm and axis length 60 mm rests with its base on HP, and an edge of the base is inclined at 45 degrees to VP. It is cut by a plane perpendicular to vertical plane, inclined at 45 degree to horizontal plane, and passing through a point on the axis at a distance of 30 mm from the base. Develop the remaining surface of the truncated prism. Before moving ahead to solve this problem number 3, I want to dictate an important note: the difference between truncated prism and Frustum prism. That is, whenever the cutting plane, kindly make a note, that is, whenever cutting plane, if cutting plane is parallel to base, if cutting plane is parallel to base of the object, then we will get frustum. Then we will get frustum of that object. Let us consider a cone. Let us consider a cone like this in front view, and if I cut it such a way that the cutting plane is parallel to the base, then we will get frustum of a cone. If the cutting plane is inclined, then this bottom portion is termed as truncated cone. So here, since the cutting plane is inclined at 45 degrees, cutting plane is inclined at 40 degrees to horizontal plane, is nothing but to the base, I am going to get truncated prism. If the cutting plane is parallel to the base, then I am going to get frustum. So if cutting plane is parallel to base, the development yields us frustum. If cutting plane is inclined, if cutting plane is inclined at angle theta to base or to horizontal plane, we will get truncation. We will get truncated portion of that object. So for problem number 3, since the cutting plane is inclined at an angle of 40 degrees to horizontal plane, I am going to get truncated prism. Here we have the cutting plane is inclined at an angle of theta to base. We are going to get truncation. I am going to get truncation portion of that object. If cutting plane is parallel to the base or parallel to horizontal plane, we are going to get frustum of that object. With this brief note, let us draw the front and top view of the given problem of pentagonal prism of base height 30 mm and axis length 60 mm. So let me draw the front and top view of the given problem, for which let us construct VP and HP. We are doing first angle projection only, that is, above XY line we will be having vertical plane, below XY line we will be having horizontal plane. On vertical plane we will be plotting the front view, on horizontal plane we will be plotting the top view. Always start the problem from top view. Before that, he has clearly mentioned that the base of and an edge of the base is inclined at 45 degrees to VP, he says. So therefore, to draw the pentagon in the top view, first I want a reference line at 45 degrees. So let me take a reference line at 45 degrees, on which I will mark one of the edges of the pentagon, base edges of the pentagon. So marking a reference line at an angle of 45 degrees. Like this. This angle is 45 degrees given in the question. On this I will mark one of the base edge The base side is 30 mm in dimension. So I'll mark one of the base side. Let me mark it here. I marked one of the base side. Done. Now using this, I'll construct the pentagon. As we know, the interior angle of pentagon is 108, whereas exterior angle is 72 degrees, using which we can construct the pentagon using angle method. The exterior angle is 72, whereas interior angle is 108 degrees. Here also I will mark an exterior angle of 72 degrees, that is 72 degrees. Done. On this I should mark 30 mm base side given. Mark 30 mm base side. Here also similarly you repeat the same thing. Mark base side given, which is 30 millimeters. Done. Mark 30 millimeters base side. Now for closing side, let me use compass. So we know how much is the dimension from the end of this edge. Cut two arcs like this. Directly which I'll get the required pentagon. So this completes the top view of given problem. Correct? Now I want the axis, because it states that cutting plane is perpendicular to VP and inclined at 40 degrees to HP and passing through a point on the axis at a distance of 30 mm from the base. So therefore I want axis. So axis is obtained by drawing perpendicular bisector from corner to the opposite edge. This you people already know how to get the center of the pentagon. Draw the perpendicular bisectors from the center to the opposite edge. This one I will take, and I'll take one more here, which will be like this. So this will become, for prism O1. Let me mark the sides. This is A1, BB1, CC1, DD1 and E1. Now extending this, I will get the bases A1, B1, C1, D1, E1. Also mark the position of the axis, that is O1 dash O dash. C1 and here finally D1. Now we know height of the axis. The axis length is 60 millimeters. For prism, all the longer edges and axis are parallel to each other. First let me lay down the axis. Axis height is 60 millimeters. So lay down the axis first. So axis height is specified as 60 millimeters. Draw axis. This is about the axis of the pentagonal prism, specified as 60 mm. Then draw all the longer edges parallel to it. So remaining longer edges are parallel to the axis and measures 60 millimeters. Measures 60 millimeters. draw all the longer edges. So this is the base and this is the apex of the pentagonal prism what we are discussing. Now in the base we have A1 dash, A dash, here we have B1 dash, B dash, here we have E1 dash, E dash, O1 dash, O dash, then we have C1 dash, C dash, finally D1 dash, D dash. So this completes the front and top view of the given pentagonal prism satisfying the condition and edge of the base is inclined at 45 degrees to VP. Now let me show the side length also. So each side measures 30 millimeters and the axis height is given as 60 millimeters. Axis height is specified as 60 mm. Axis height is 60 mm and the cutting plane is passing at a point on the axis at a height of 30 mm from the base. So measure 30 mm as a reference. Measure 30 mm as a reference. Measure 30 millimeters as a reference, which is nothing but it is bisecting the axis because axis height is 60 mm whereas cutting plane is passing at a distance of 30 mm, which means that it is bisecting the axis. Mark 30 mm. Now at a distance of 30 mm from the base, the cutting plane is inclined at an angle of 45 degrees. So let me have a reference line to mark 45 degrees. Now keeping the protractor at a point at a distance of 30 mm from the base, measuring 45 degrees. Measured 45 degrees. I laid on the cutting plane. Let me use different chalk for that. So draw the cutting plane. So drawing the cutting plane will pass like this. Draw. This is the portion which I should retain. Mark it. This is the portion which I should retain and the upper portion will be removed. Now, as I already mentioned, inspect longer edges first and then inspect whether it is cutting the base edge or not. Coming for A, longer edges A1 dash to A dash, the cutting plane is intersecting here, mark this as 1 dash. Check for base, that is A to B. So A to B is neither cut at the bottom nor cut at the top, so leave it. Next move for B, B1 dash to B dash. So it is cut down here, mark it as 2 dash, inspect the base, that is B to C, it is unintervened by the cutting plane. Here also B dash C dash is also unintervened by the cutting plane. Next move for C. After B we have C here. So longer edge is C1 dash to C dash. So this will become 3 dash. Next inspect the base, that is C to D, at the bottom, at the top. So neither at the bottom nor at the top it is intervened by the cutting plane, leave it. Next move for D. D1 dash to D dash is cutting here, so mark it as 4 dash. Next check the base, that is D to E. D to E is unaffected, D to E is also unaffected at the bottom as well as at top, leave it. After D, move to E. So coming for E, E1 dash to E dash is cutting here, so mark it as 5 dash. And inspect the base, that is E to A, E1 dash to A dash, at the bottom nor at the top, E dash to A dash, is cut down by the cutting plane, so leave it. So thereby we have marked points 1 to 5. Now if you observe, none of these points are coming out at the base edge, at the bottom or at the apex. So therefore all the points can be transferred just by drawing the parallel line. If and only if the cutting plane is cutting the base, the shorter edges, either at the bottom or at the apex, then only we should measure the distance from the top view. So since none of the points are lying neither at the base nor at the apex, so no need to worry, just by drawing the parallel line I can complete the development of this given problem. Before which, first I should lay down the development of the pentagonal prism. First, if I cut down this pentagonal prism from one of the longer edge and unfold all the lateral surfaces, I am going to get 5 rectangular faces of dimension 30 mm cross 60 mm. Right? So first let us unfold this pentagonal prism first. For that, let me extend a line here and unfold the pentagonal prism. If I unfold a pentagonal prism, I am going to get 5 rectangular faces of dimension base edge cross axis length. The base edge is 30 mm, so therefore I will get 5 into 3, that is 150 millimeters is the overall length. So mark 5 faces, 1, 2, 3, 4 and 5. How much is the height? Height is 60, which is given. Mark 60 millimeters vertical height, which is same as the axis length specified for us. So lay down the vertical lines of height 60 millimeters, then connect the top. Connecting the tops of this, I will get the unfolded development of the lateral faces of this pentagonal prism. Each of this measures 30 millimeters and 30 into 5 gives us 150 millimeters. So I unfolded the lateral surfaces of the pentagonal prism. Height is already specified here, 60. Now this is neither front view nor top view. As usual, I use the convention as capital A1 at the base and A at the top. This is B1, B, C1C, D1D, E1E, and finally the first and last longer edge should be same, because when I fold it, the first longer edge will overlap with the final longer edge. Now let us transfer these points from 1 to 5 dash. For longer edge A, we have 1, so draw the parallel line and transfer it first. So drawing the parallel line, I'll transfer 1. So this should be transferred for the last line also. So extend it till it touches the final longer edge, that is here. So this is also 1. Here also we have 1. Next for B, we have 2 here. So transfer this 2. Transferring this 2, we have like this. So transferred 0.2. Next for C, we have 0.3 here. So draw the parallel line. So drawing the parallel line for 3. 3 is to C. So this will become 0.3. Next we have 4 here, that is for D. Draw the parallel line to D. So this will become 0.4. Next for E, we have 5 here. So draw the parallel line to longer edge E1. That will give us 0.5. So this completes the transferring of points 1 dash to 5 dash into the development. Now connect these points by sharp edges 1 to 2, 2 to 3, 3 to 4, then 4 to 5, 5 to 1, and connect the bottom. So since this is a prism, we have sharp longer edges as well as base edges. So dot these remaining longer edges, remaining portion of longer edges as well as the base edges, that is A to B, B to C, C to D, D to E, and E to A. So this bottom portion will be retained and the top portion will be removed. So this is the one which we have dark using the blue chalk is the development of given problem. This is the development of given pentagonal prism which is cut out as shown in the front view of this. Before concluding this problem, we have inclined the cutting plane at an angle of 45 degrees. So therefore, make the question also as 45 degrees. The cutting plane is inclined at an angle of 45 degrees to HP. This is because we have inclined the cutting plane at an angle of 45 degrees to the base. What he has given is at 40 degrees, but I have solved it for 45 degrees. Hence, change the question accordingly to 45 degrees. So this is how we should solve. So this is the solution for problem number 3. That's all from this lecture. Thank you all.